Good afternoon, or is it good evening yet? One of those, right? Almost evening. So is the last session of the day better than the first session of the day in the schedule? Yeah, okay, good. So thank you for coming. This is automating System Center deployments using the PowerShell Deployment Toolkit. I'm Rob Willis. I am a Principal Program Manager in the Windows Server and System Center engineering team in Redmond. And I'm the guy on the Building Clouds blog team that put together this thing called PDT, or the PowerShell Deployment Toolkit. How many people are familiar with the Building Clouds blog? Okay, I'll be referring to that a little bit as I go through this. How many people have been to one of my sessions on PowerShell Deployment Toolkit before? A handful, okay. I'm going to give a lot of the same overview that I've given before and then talk about some of the new capabilities that we've added in the last year. PowerShell Deployment Toolkit, or PDT, is a set of scripts and knowledge that you can use to deploy stuff, and the samples that we provide with it are really focused on deploying System Center. So I'm going to start with some questions, and if you've been to a session before, you know the answers, so you can't answer. How many products make up System Center 2012 R2? Shout it out. 8? 7? Who said 1? 1. There is one product called System Center 2012 R2. You buy one thing, you license one thing, and you get a whole bunch of stuff as part of that. How long does it take to deploy that one product? Somebody say a year? It takes too long, is the only answer. I've had answers from a week, 2 weeks, a month. I don't think anybody's ever said a year before. It takes too long. Actually, the answer to that first question, one of the former directors of program management, he asked the question, and his answer was always just too many. There's too many products. There's actually only one. How many screens, if you're doing a manual installation of all of System Center, including all the prerequisites, including SQL Server, how many screens do you click through? 1,522? It's a lot. I was the PM for the Unified Installer in the original System Center 2012, so I apologize for that. But I did actually count it, and that was actually a very simple deployment the Unified Installer did, and there were 422. If you're doing a real deployment, there's a lot. How many post-setup integration tasks are there? What on earth is post-setup integration? It's too hard. Who's afraid of XML? Come on, don't be shy. Who's afraid of XML? Okay. I'm going to have a pleasant surprise for you by the end of this presentation. So we'll just leave it at that. But I am warning you, there is manual editing of XML during this session. Please don't leave. There's a good answer at the end, but I want you to understand how this thing works. So again, there's some good news coming. I'm going to start with some demos. And the reason I do this is because I'm going to do a few deployments, and we're going to take a look at them as we go through, and I want them to be finished by the time I'm finished talking so that we can look at the results. So I'm actually going to start 3 deployments. The first one is what I call a full deployment. If I can type, and I'm going to just tell it to skip the validation here. Okay, this is deploying more or less everything that's in System Center 2012 R2. The second one is a HA deployment. This is maybe a typical service provider type deployment. There's a SQL cluster, there's a VMM cluster, there's load balance roles of a number of different things. So a full HA deployment kind of in a service provider scenario. And then the third one is a lab setup. So I'll be honest, those first 2, they're actually partially deployed already. They don't complete in an hour anymore. So I did a partial deployment, and they're picking up where that one left off, and I'll explain how we do that later on. This one is a complete deployment. Everything from absolutely nothing to deployed. It is a relatively simple one. It's just a 3 VM orchestrator installation, but this is on a Hyper-V host that currently has no VMs. So I'm going to just start the VM creator here. And so now I've got my full deployment started, my HA deployment started, and VM Creator lab deployment started. And we will come back to those as we go through. So HA deployment, VM Creator. So System Center 2012, one product. That one product is made up of a number of components, and somebody said 7, and that's the real answer in terms of number of components. How many people here are using, well, is anybody here not using any of this? Okay. How many people are using 2 or more components? 3? 4? How many are using all of it? We got 2 hands, 3 hands. Okay. The point is there's a lot of value in System Center. And really get the value, you get it from using all of the capabilities in here. And actually, I tend to include the Windows Azure Pack as part of this. It's not part of System Center, but it is very much included or wrapped up in the deployment. But you break that down a little bit. From components, you now have roles. Right? Each one of those components has a number of roles. This is by no means a full list of all of the roles. If you really wanted to take it to an extreme, Windows Azure Pack also has websites, Service Bus, SQL Cloud. Configuration Manager has a lot more components than here. These are basically the roles that the core setup of each one of these components actually goes through. Then you take it a step further. Each one of these roles has 1 or more prerequisites. And there's a lot of them. Some combination of this you have to install before you can deploy those roles. And actually, this is by no means a full list. This was the list for System Center 2012. There were more for SP1, there's more for R2, and there's a lot more for Azure Pack. So the set of things that you have to get installed and set up to do a System Center deployment is pretty extreme. The goal here is to make this truly a single product with a single deployment capability so that you don't have to know what prereqs are needed. You don't have to know details of how SQL needs to be configured. You don't need to know how to integrate these things with each other. And increasingly, especially with the Azure Pack, that's becoming more and more complex. You just deploy one thing and you get to value a lot quicker. Because installing stuff is not interesting or fun. Using the capabilities it provides is really where you get the value. So what's the experience today of installing System Center? First, define your deployment. I don't care how much automation you have, it does not replace appropriate planning. The services guys, the consultants in the room always appreciate it when I say that. You can do a default deployment with some of the samples I provide and it will work, but it won't work very well. You have to define your deployment, you have to do your planning. Don't skip that step. Then you go and download all the bits, if you can figure out what they are, some of those combination of prerequisites and everything, SQL and everything before. Then you go and you install a bunch of servers. Typically today you'll do VMs, you may still have some physical servers, but you have a bunch of server instances that you set up that you're going to now go and deploy System Center to. Then you create some service accounts. Then you log on to each one of those servers and start installing the prerequisites. Actually, what you probably do is you run setup for whatever System Center component you want to install, and it says you're missing the SQL native client or the SQL command line utility. And so you go and you download that and you try and install that and it says you're missing the SQL native client. So you go and you download that and eventually you get to the point where you can actually install one of the System Center components. But you install prereqs, you go ahead and you install SQL, then you install SQL again because you did it wrong the first time. You got a collation wrong or you put the log files in the wrong place. You didn't find that out until you tried to install Service Manager about 2 weeks later, but you're probably going to install SQL several times. Or you're going to go to your DBA team and have them install SQL, and they're going to lock it down so tight that nothing can ever use it, so then you're going to do it yourself. But eventually you get SQL installed. Then you figure out which of those service accounts need which permissions. Typically administrative permissions, but not always. Then you go and you install your first server role. And then probably install other server roles, depending on which component you're installing. And then you figure out how to give people access to use that component, so you give them admin permissions to the component. And then if you know about this post-setup integration thing, you go and you do that. Then you install a console. Then you tell the console which one of those multiple servers it needs to connect to. Then you install some agents. Finally, you get to manage something, right? This is not an optimal experience. With PDT, it's very different. We don't replace all of it, but the bulk of this is replaced by 3 scripts in the toolkit, in the deployment toolkit. We do not automate planning. You still have to plan your deployment. So we're going to walk through each one of these and look at how PDT actually automates this. So first, you define your deployment. And here comes the XML. This is actually very simple. There's 5 files in the deployment toolkit. There's 3 scripts, 3 PowerShell scripts, and 2 XML files. The only one of them you need to change, modify in any way, is variable.xml. This is the one that defines the deployment that PDT is going to do. The download itself off the TechNet gallery comes with a couple of samples. So at its simplest, you can just go and modify, edit that sample. What you do in variable XML, you specify some global settings. So you'll have the user and company name that the components are going to get registered to. There's a service account that's actually going to be used for the installation. There's a source path to where all the bits are, and we'll get to that in a moment. Then optionally, you can also put in product keys. Then you specify settings for each component. Typically, that's just a service account or a number of service accounts and passwords for that component. There may be a couple other things in there, but typically it's just service accounts. You can define a lot more, but that's more custom. By default, all you have to do is the service accounts. Then you say which servers you want each one of these roles to go on. So database roles, you've got to specify a SQL instance as well as the server, but everything else, you just tell it which server it's going to go on. For each SQL instance that's going to get installed, you have to specify which version of SQL you want to use, 2008 R2 or 2012, and which group you want to be the administrator of that SQL instance once it's installed. And don't worry, because the installer the script itself actually validates everything you put in there. Right? So if you get something wrong, 95% or so of the time, validation will fail, and it won't let you continue. There are a couple of things that it still doesn't quite catch, but most of the time it'll validate what you specified. So this is a sample. This is a very simple example, and I use Orchestrator as my examples a lot through this, mainly because Orchestrator is really quick to install, so it works well for demos. But this is a simple Orchestrator example. We've specified the installer account. That's not going to be used for any of the services. That's just used for actually performing the installation. We specify variables for the component. So in this case, it is just service account and password. Which servers we want those roles to go on. So this is a separate database server, one server for the Orchestrator box, and then I've got a remote desktop server specified here for the console, for the runbook designer. Which version of SQL I want to use and what the admins are going to be. And then in this case, I have not defined product keys. So if you leave product keys out, you get an eval install. If you give it product keys, you'll get a fully licensed installation. Okay, so that's defining your deployment. That's really where you do all of your planning. There's a lot more that you can put in there in terms of variables for each one of those components, but that's a basic example. Then you go and download all the bits. Right, for this is where our first script comes in. There's a downloader that will go and get everything you need, almost everything you need for you. So what the downloader actually does is it downloads all the prereqs. It does not download the system-centered components anymore. I'll explain that in a moment. But it goes and it gets SQL, it gets all the prerequisites, report viewer, native client. It gets the management packs you need. It gets SharePoint for the Service Manager portal. It basically grabs everything that it can for that deployment. If anything needs to be extracted, so if anything is an ISO file, a zip file, or a RAR file, it will automatically extract the contents of that file for you. Anything that then needs to be run to go and get further content, it will then run it for you. So, for example, ADK is about a 36K download. you run it, and it downloads about 2 gigabytes more of stuff, right? So it actually does that for you. It also runs the configuration manager downloader. You know, when you go through config manager setup, at one point it says, where do you want to put the things I'm going to go download? It runs that for you. Anything that's in a self-extracting executable, it will run that, so it'll extract the contents of that. And it also runs the web platform installer to download content for Azure Pack websites. Then it slipstreams SQL 2008 for you. So it takes the service pack files and slipstreams them for SQL 2008 R2. Doesn't need to do it for 2012. That works in a slightly different way. The system that you run Downloader on requires you to be running on Windows Server 2012, Windows 8, or newer. It requires you to have either WinRAR or 7-zip installed, and it also now requires you to have the web platform installer installed. It will warn you if it doesn't have any one of those things. There's one option on the downloader, which is dash deployment only. By default, it downloads everything that PDT knows about. So everything for SP1, everything for R2, everything for Azure Pack, everything for websites. If you specify dash deployment only, it will download only the things it needs for the deployment you have defined in your variable XML. And it is restartable. It is, last time I checked, about 15 gigabytes worth of stuff that it downloads. Once it's extracted all of that, it's 30 plus. But if it stops, if it fails, if you turn the machine off halfway through, you can restart it. It will re-download full files, but it won't download anything that it's already got. It does not download the Windows Server images or System Center components. It used to. It doesn't anymore. The reason for that is we put a registration required in front of those components. So if you go and get those, to get those eval components off Microsoft.com, you have to register first. So the downloader can't register for you. You have to go manually and get those. But it will warn you now that if you haven't got those, that you need to manually download them. So let's take a look real quick at the downloader. So each time I flick the demo, I'm going to look at the status here. This is our full deployment. Green means I'm done. Yellow means I'm waiting on some role on some other on another server before I continue, and white is I'm actively installing something. The reason SQL went green very quickly, I told you these were partial deployments. SQL is already installed, right? So it just immediately said, okay, I don't need to do that, that's done. So our full deployment, ticking along. HA deployment, that's a 3-node SQL cluster on each one. And then this one, it's created all the VMs, and the domain controller has set itself up and is currently waiting for the other VMs to join the domain before it continues. We'll get to more details on that in a moment. So, downloader. I actually already have everything downloaded on this system because we don't want to sit and watch 15 gigabytes download. How many downloads do you think there are? Just take a wild guess. For all of SP1 and all of R2 and Azure Pack and websites and Service Bus and SQL Cloud, how many things does it need to download? 32? I can't remember. It will tell you. $99. It's a lot of stuff. What it's actually doing, it's checking each one of those downloads to see whether you already have it, and if you already have it, if it's the right file. And in this case, it already got everything, so it just skips right through. But if I was missing something, so let's say, for example, I go and I delete, let's delete Silverlight. If I'm missing something and I run downloader, this time you should see, after it's done its check on all the file sizes, okay, the internet's slow. How about that? I froze it, didn't I? Yes, thank you. Watch it live this time. it will download, and it's already done it now, so it will download that one component. If you have one of the missing, if one of the missing components happens to be one that we can't download, so for example, if I just rename the folder the orchestrator is in here, it can't download that because it can't register for you, but it is going to warn you that that one needs to be manually downloaded. So if you run downloader and you get no yellow messages, it basically means you've got everything you need. The option on this is deployment only, and this time instead of 99 things to download, it was only 6. So it looked at the variable file, which on here is just orchestrator, and it calculates what it needs just to do that deployment. If you don't have the utilities installed that you need, so 7-zip or WinRAR WebPI, it'll tell you that it's missing something it needs to do an extraction. So if you run downloader all the way through, you get no yellow or red messages, it basically means you've got everything you need. And so you can run downloader one time, get everything you need. If you're a consultant or a services company, put that on a USB stick and take it with you. Don't make your customer go and download that every time, but it's a pretty simple way to get everything you need. Okay, so now we've got our bits. We need to go and install all those OSs. For this, we have the second PDT script, the VM creator. Now, somebody would say, well, you're a system center guy, the virtual machine manager creates VMs for you, so why have you written something that creates VMs? We haven't got virtual machine manager yet, that's the whole point, we're deploying it. So this is a pretty simple way to go and create a set of VMs. It is completely optional, you do not have to use this. All we need is Windows Server OS images of the right version. Don't care whether they're physical, virtual, or which virtualization platform they're on. Yes, actually I do care which virtualization platform they're on, but System Center doesn't, it'll work on any. So if you already have some way that you've created those VMs, that's fine. They just need to be the right version of Windows Server, they need to be domain joined with WinRM enabled, and you need to have admin permissions to them. If you don't have them, VM Creator will create them for you. So you specify how many servers you want, you set some defaults, so which host, Hyper-V host you want to install it on, and yes, VM Creator does only create VMs on Hyper-V. Somebody in the audience modified it to create it on VMware as well, and that's just fine. These are scripts, you can modify them for your need, but the one that we provide creates on VMware, on Hyper-V only. You specify a VM name, and in the defaults you just give it a prefix and a sequence, and it'll count that sequence to name those VMs. How many CPUs you want, what memory you want, settings for the network adapter, all the normal things you'd expect to create a VM. There is a full example of this in the variable XML on the download. Then if you want to have different values for different VMs, you can override them. So typically I always name my VMs by what's going on them. I don't use just 1, 2, 3, 4, 5. So you can specify an override for any one of those settings per VM. Then the creator, the VM creator, actually will check that all the things it needs to be able to deploy that VM are present. So a virtual network with the name you specified exists. A parent OS disk exists. The Hyper-V host itself that you're going to deploy on exists. And the VMs and the files that you're going to be creating don't already exist. It'll then create the VMs, joins them to the domain, and enables WinRM and adds the installer service account to the administrators. Right? So really all it's doing is, by default, it does a differencing disk creation. You can also specify that it copy the full disk, but by default it'll do a differencing disk creation of a new VHD. It mounts that VHD, inserts a syspret file, modifies the syspret file based on whichever VM you're creating, including adding it to the domain and making the installer service account a local admin. So again, a pretty simple example here. In this case, I've just said I want to create 3 VMs called Server 11, 12, and 13, except the first one I actually want to give it a slightly different name and more memory than the default ones have. So this will just go through and create 3 VMs for you called SQL 01, then Server 12 and 13. There is one option on VM Creator, and when I presented this last year at TechEd, I gave a sneak preview of this. This is now available in the currently released version, and this is VM Creator with Active Directory. So this is a single pass lab setup, if you like. Right? The default VM Creator will attempt to join an existing domain. That's how most deployments actually are done. But if you're doing a lab setup, if you're doing a proof of concept, if you just want to try something out completely isolated, it will actually do a full pass create AD for you. What it actually does, it takes the first VM that it creates, and as well as injecting the sysprep file, it inserts an auto logon script that will go and configure that machine as a domain controller. So it creates the first VM, inserts that set of scripts and sysprep, starts that, and then continues and creates all the other VMs, but doesn't start them. The first machine will install itself as a domain controller, and then it waits for all the other VMs to be joined to the domain. Once those other VMs are joined to the domain, it then automatically runs the installer, the PDT installer, which we'll talk about in a moment, to actually go and do the deployment. So that was and the only thing you need to do to make that happen is one extra section in the variable file in VMs and just say, this is a domain deployment. Right, so that was the third demo I started at the beginning. And so you'll see what happened here was it installed my first machine. And as it was creating that VM, it calculated all of the files, all the bits that are required for that deployment, and added those to that VHD while it was creating that VM. So by the time the VM starts up, it has a local copy of all the content it needs to do the deployment. Then it starts the first one. You see right in the middle of the screen there, it says starting DC01. Then it goes through and installs or creates all the other VMs. And then at the end, it sits and it waits for the DC to be finished. And it actually does that using key value pairs. So this can be a completely isolated network from the Hyper-V host. It just uses KVP to determine when that DC is finished. And once it's detected that it's finished, it starts all the other VMs, which then join the domain. And the DC, let's set this so you can see everything, then detects when those other machines are started and automatically begins the deployment. So this was nothing pre-staged. It's doing everything from start to finish. Right now, the remote desktop machine, which is actually the domain controller, has the runbook designer installed. That's finished. The orchestrator machine is waiting for the database to finish installing. SQL obviously takes longer than most things to install, so they've finished doing all their prereqs, but they're waiting for SQL before they can continue and actually install orchestrator. So that was VM Creator with AD. Okay, next we create some service accounts. I don't automate that for you today. We're looking at adding a script to the set that will automatically go and create all the service accounts and groups you need, but there's no assumption, other than when you do VM Creator with AD, there's no assumption that you have any special access to Active Directory other than just a regular user. So you have to have all those service accounts and groups created. Then, normally you would go and log on to each server. We don't do that. Everything that PDT does, it does remotely. And this is actually one of the most interesting parts of putting this thing together, was how to do that. The requirements we have are, I need to be able to run a command on some remote server, and that command needs to execute with credentials delegation. That means that it has the ability to install something on that server, but then also reach out to some other server to perform some action, typically create or access a database. Right? It's double hop authentication, it's called credentials delegation, and it's the biggest problem we had to solve in putting this whole thing together. There's a number of different ways to do this. WMI, you can start a process that doesn't give you credentials delegation or anything even vaguely intelligent like that. WinRM would seem to be the right choice, right? Windows Remote Management is our preferred way of doing most things remotely. WinRM itself doesn't allow credentials delegation unless you enable cred-SSP. And honestly, that would be the best choice, except there's a problem. It doesn't work. The problem is that there are certain things that you can't run with WinRM. Specifically, two things. You can't run something remotely with WinRM that configures and restarts WinRM. It's effectively killing itself halfway through the process. You also can't do anything remotely with WinRM that involves a Windows update. And this was the bizarre one. The Windows Update standalone installer, youre, actively blocks you from remotely running itself in a remote session. It requires a local logon to be able to actually execute. Now, yes, we don't have to install a lot of updates, but the problem is youre is also used to check to see whether an update is required, and a lot of setups actually check to see, as their prereq checks, to see whether an update that they need is there or not. SQL does it. .NET 4.0 did it on Windows 2008 R2. DPM does it a lot. All of those things fail on any remoting technology, so WinRM, even with cred-SSP, wouldn't work. There's also psexec, or specifically psexec with the /s option, which says run as system, so now youre doesn't know that it's remote, it will actually work. But with /s run as system, it doesn't have credentials delegation, so it can only do something locally. So that won't work. psexec also gets reported as malware by a lot of anti-malware tools, so we really didn't want to have that popping up all over the place. Orchestrator has an option called run program. Run program is actually just a modified version of psexec. All right, so it has the same capabilities and the same problem. The way we did it with the unified installer in the original System Center 2012 was we actually used an Orchestrator runbook server, and this would still be an option, except it's a lot of stuff to install just to get remote execution. So we found a better option, and that is the task scheduler. The task scheduler, when something executes within task scheduler as a service account, as an account you provide it, Windows sees that as a local logon. So it has permission to do something on that machine and reach out to a remote machine. It also doesn't have to be scheduled. It can just be a task that you create and then manually start. And so that's exactly what we do with PDT. We register commands in the task scheduler remotely without a trigger, which means they're not scheduled. Then we start it, wait for that to complete, and then check to see whether it did what it was we wanted to do. So effectively, we're using the task scheduler as a remote agent. It's very effective. There was some concern that people had around using task scheduler, but that kind of goes back a long way with Windows to the old task scheduler, whether it was not the most stable or secure component of Windows. Task scheduler is absolutely a required component of Windows. If you've disabled it on a Windows server, there's lots of things that should be happening that aren't. So this works pretty well. There is one policy that can block it from working, and that is a credentials policy. There's a policy in Windows that says don't allow tasks to be registered with accounts. Right? If you have that policy set, PDT won't work. But we check for that in validation to make sure that it's not set and warn you if it is. So, what do you think we do next? Everything else. All in one go. PDT installer does more or less everything else. We don't install agents. We still require you to choose which systems you want to have your agents on, but the installer then does everything else that's required. Installer is just a distributed deployment controller. It knows nothing about System Center. All it knows is how to create tasks on remote machines, validate whether something is required or something is completed successfully, sequence a set of tasks to happen, and manage dependencies between multiple systems in a deployment. It manages reboots where they're required, and it also gracefully handles cascading failures. What on earth does that mean? If I'm installing components across a number of machines and machine 2 is dependent on a component on machine 1, and the installation of that component on machine 1 fails, machine 2 now nothing on that machine has failed, but it has a dependency that's failed. And that could cascade potentially through a number of machines in a deployment. So the installer knows how to manage that type of dependency check and that type of cascading failure. It works in a number of phases. It will add service accounts where required to the local administrators group. It will install Windows roles and features. It installs SQL, both clusters and standalone instances of SQL, and then it will install a whole set of prerequisites. This, with the exception of the SQL clusters, have no dependencies, right? If it's installing a SQL cluster, it manages the dependencies between nodes in that cluster, but there's no other dependencies in this. Every machine in a deployment can do all of this without checking anybody else before it gets to the point where there's a dependency. Then there's dependencies between servers to install roles. So if I'm installing Orchestrator, I have a database, I have a management server, and then I have runbook servers. The management server is dependent on the database. The runbook servers are dependent on the management server, right? But I can install all the prereqs for them at the same time and then start checking dependencies between those multiple roles to see when each one can start. So there's dependency checking once we get to the point of roles, which is why on my deployment, SQL was finished, and I pre-staged SQL, but if I'd also done prerequisites, those would already be installed on all the other machines because there's no dependencies from them on any other machine. Installer itself knows nothing about System Center. All it knows is how to do a distributed deployment. All of the knowledge, remember I defined PDT as a set of scripts and knowledge, all of the knowledge is codified in an XML file called workflow. It's currently around 35,000 lines of XML. This is essentially everything that we know about how to deploy System Center in a declarative file. It defines what the roles are, what the requirements for that role are, how to validate whether that role is installed, what dependencies that role might have on other roles, what firewall ports need to be set, what needs to be downloaded, what needs to be installed for that role to be effective. It also defines some global settings. So we looked at variables a little bit earlier on. All of the variables, every variable that you can put in the variable file has a default value in the workflow file or a blank value in the workflow file. So if you want to really explore how to customize the deployment, everything is in workflow. And it is completely extensible. I've been saying this for about 1.5 years now, and nobody's ever actually questioned me on it. The way it was extensible before is you could modify workflow XML to add something. So I've said every single time I've given this presentation, if a partner such as Veeam wanted to deploy their management pack using PDT, they could extend the workflow XML and allow it to deploy their management pack as well. I know some people have done it, but it involved changing the workflow file. And we release updates to this fairly regularly, right? So it means you'd have to go and track those updates and go and put them back in. We have a new solution to that, so it is now extensible without modifying the workflow file. So I'm going to go and look real quick at, well, first, let's see how our deployment's doing. More things are turning green. And other things waiting. HA deployment, something's failed. That's not good. This is now a troubleshooting session. So actually, no, let's go back to that. If something fails, if PDT detects that something has failed to install, it will turn that role red to say there's a failure. And we'll talk about troubleshooting in a moment. I could pretend this is intentional. It's not. So this is the workflow file. As I mentioned, 35,000 lines of XML. I can make this a little larger. Is that easier to read? Okay. Everything is keyed off what we define as roles. So I'm going to use Orchestrator as my example. So here are my Orchestrator roles. The database server, all it needs is .NET 3.5.1, so here are the server features that are required, and then it needs SQL using a default collation and just the SQL engine feature of SQL Server. Pretty simple role. The management server isn't a whole lot more complicated, same features, but it now has a dependency. So we're saying here the management server has a dependency on the database server, so I can't start the actual role install until the database server is complete. And when I actually want to do the install, it links back to an installable, right? So this says in the orchestrator media, you install the management server. So that ties back to our installables. And here is the orchestrator installable. An installable is basically a piece of media that the downloader will go and download. An install then defines a command line. So in this case, here's the product key that's used to validate whether or not it's installed. Everything that the installer does, it checks to see whether it needs to do it before it does it. Right, so if we've said install orchestrator, but orchestrator is already installed, it'll just skip that step, which means you can rerun it, you can restart it. And this is what it used to actually validate that. And then it defines one or more command lines. Right, so here we're telling it to run setup off the orchestrator media, and here are all the switches that are passed to that. Some of these switches have conditions. So this is the product key. If you've supplied a product key as part of your variable file, it'll pass that to the installation, and you'll get a license install. If you haven't, it'll just skip that switch when it does the installation. So everything is defined in here. There's also the default variables. So these are the variables that you could choose to set for orchestrator, right? So most of these, you're going to leave defaults. You're going to change the service account, but you're probably not going to change the ports that the web service and the web console are running on. So you can just leave those, just stay in the workflow file. You don't need to change those. Then we also have something called integrations. Integrations are that post-setup integration thing I talked about. These are installed just like their roles. They have dependencies on other things. They're installed just like roles, but you don't have to define them. PDT automatically determines which ones of these it needs to do. So for example, if I'm installing Virtual Machine Manager and Service Provider Foundation, right? Those two things are always tied together. Here's the integration that defines it. So if these two roles are part of my deployment, this integration will automatically be added to the deployment. You don't have to define it. And this is the server whichever server has that role is the one that will run that integration. So post-setup integration, you don't even need to know about it anymore. It automatically happens as part of the deployment. Everything gets validated. Almost everything gets validated. The first version of this we put out February of last year had no pre-installation validation. It just assumed everything in the variable file was correct. I learned very quickly that was a really bad assumption. Right? So the first thing we added was validation. It runs through 3 different phases of validation. It runs through local validation, and all that's doing is checking the content of the variable file to see whether what you've put in there makes sense or not. So for example, every server role has to be specified as an FQDN. If I'm installing a role that has a dependency, it validates that you've specified the dependency. So if I've tried to install an orchestrator management server without an orchestrate database server, that's not going to work. It doesn't let you do it. It validates that you've combined things in a way that should work. Right. So for example, you can't install Service Manager and Operations Manager on the same server instance, OS instance, so it makes sure you haven't done that. It makes sure you only have the appropriate count of instances of roles. So you can only have one orchestrated database server. If you've specified multiples, it won't work. It'll stop you from doing that. It makes sure that all of your required variables are installed, are specified, and that you've got SQL instances specified for each database role, and then that you have all the media you need to complete that deployment. Then it starts checking other remote things. First one it does is Active Directory. It makes sure that all the service accounts and passwords you've specified are correct. If there's other security principals that could be either a group or a user, it makes sure that that exists. It doesn't need to check passwords on that, it just makes sure it exists. And then it checks remotely each system that you're trying to install against to make sure that server actually exists. You have admin access to it. If it's part of a cluster role, then it makes sure that the servers are in the same cluster. Make sure WinRM is enabled, the task scheduler enabled, that credentials policy I mentioned earlier isn't set, and it has the right operating system version. It makes sure it has file access, because we copy all of the files for installation to that server before it gets installed. It doesn't do certificates anymore. There's actually no requirement on that anymore. The validation check's in there, but nothing requires it. And it makes sure that the system has at least the minimum amount of memory to install the role that you're going to install. Okay. So almost everything that we know can cause something to fail, we check before we start, rather than let it fail and have you fix it afterwards. So I'm going to go and show you what that looks like. What doesn't get checked? There's a couple of things that we know about causes it to fail that we don't check right now. So when you're installing VMM in a cluster, it requires a container for distributed key management in AD. It doesn't check that the container exists and you have access to it. It's the only one I can think of off the top of my head. But there are kind of what I think of as edge cases that can still fail there. Okay. So here's our variable file for the full deployment. All these roles, let me expand that a little bit as well. Okay. This is actually the same as number one, it's just not running, so I can do things without breaking that first deployment. So if I were to, for example, do something that doesn't make sense. Let's try and install Service Manager. So here's my Service Manager management server on SM01, and here's my Operations Manager on OM01. Those two things can't work on the same system. So if I tell this, is that right? Yes. And then go try to run the installer, there's a validate only switch on installer. Right? If you want to check everything before actually doing the deployment, you can run it with validate only, and it's just going to run the validation, and even if it passes, it won't continue. So first couple ones will fail. Then I'm looking at combinations, and it's found those two servers, those two roles I've tried to put on the same system, but they failed that validation, so it won't let you continue. If I fix that, so back here on Service Manager, but this time remove a role, right? So I'm trying to install Service Manager. If I don't have a database server, this will fail a different validation. It should fail the dependency validation. It's saying you're trying to install a Service Manager server without a Service Manager database server. That won't work. Put that back. Let's do a slightly different failure. If I get the password wrong for a service account, you also have the ability to skip certain types of validation. So in this case, I'm going to skip all of the local validation, so it will just go straight to Active Directory. Comes straight up and says that installer service account is invalid. It doesn't tell me why it's invalid, it just knows that that's not a valid set of credentials. Incidentally, skip validation, if you just get so frustrated with validation that you think it's wrong and it's going to work, by all means do skip validation all. It will probably fail, but sometimes it does work. And the reason I say that is there are some things in here that do work, but they're just not really a good idea. Right? So you can combine all of the database instances, on all the database roles on a single database instance. It's a really, really, really bad idea, but you can do it. The validation will fail, so tell it to skip that validation and go ahead. It won't be the most pleasant experience, but it will work. Okay, let's do one more. Let's get the name of a server wrong. So will fail a remote validation. So this time I'm going to skip local and Active Directory. And this is actually reaching out to each one of those servers in the deployment to see whether or not it has access to it. And there you go, the one that I gave it the wrong name, it fails to find that server. So we're attempting to stop you from doing almost anything that you shouldn't. So the question was, are all the validation switches and options documented? I'll get to that at the end. Everything, there's a blog series that explains how to use all of this, and I believe it's in there, but I'll show you where that is at the end here. Okay. Then it does integrations. PDT automates almost all of the automatable integration. Right, and again, this isn't a full list. The part of this list that is pretty extensive, that wasn't really put on the slide, is anything related to Windows Azure Pack. Right? Windows Azure Pack was added in the last year to this when it was released, and it integrates to a lot of System Center. It does all of those, but those aren't listed on here. So there's one fairly notable missing integration, and that's Orchestrator Integration Pack registration, which is ironic. So it connects VMM to Ops Manager. It connects Service Provider Foundation to Virtual Machine Manager. It connects Service Manager to everything, because Service Manager wants to connect to everything. There's integration between DPM and Operations Manager. It does that. It connects the Azure Pack to Service Provider Foundation. It connects the Azure Pack to Service Management Automation. It even does usage integration, which involves VMM, OM, SPF, Azure Pack, and service reporting. There's about 7 different sets of integration you have to get all of that usage within the Azure Pack working correctly. It does the whole thing for you. You don't need to know anything about it. Then we have extenders. So I mentioned workflow is completely extensible, but before the latest release, you had to do that by modifying the workflow file. You no longer need to do that. There's a concept called extenders, which are additional XML files that you can add, or a partner can add, that will extend the functionality. These basically have exactly the same format as workflow XML. So they define installables, components, roles, integrations in exactly the same way that workflow does, except they are read separately from workflow and merged in memory at runtime to create an in-memory XML file that adds all of those extenders into that core workflow. There is only two slight oddities about the way extenders work. The first one is role combinations validation tends to fail when you're using an extender, because you're defining an additional role and the workflow file doesn't know anything about that role. It can't validate the combination. And so there's a switch now called skip validation roles combination. You just tell it to skip that part. The other strange thing about them is anything in an extender always gets executed last, right? It's the very last thing that happens from that section. So if I'm installing a set of roles on a single server, I can't make something from an extender install before a role from the core workflow. I haven't found an example where that's a problem yet, but I can see it could happen potentially. So new switch for if you're defining new roles, which is skip validation roles combination. And I have some samples of these, which I'll show you. The first one is, I mentioned the VM Management Pack. So the VM Management Pack for VMware has some roles that you install. There's a virtualization extension, there's a collector, and then there's a management pack that you put into Operations Manager itself. The extender for the VM Management Pack installs all of those for you. Grid Pro, it's okay, I was going to ask the question, how many people are using VMware? Come on, be honest. Okay, if you haven't looked at the VM Management Pack, you got to do it. If you're using Hyper-V, you still got to do it, because the new version of their management pack monitors Hyper-V as well. It's awesome. How many people love the Service Manager self-service portal? Not very many. Grid Pro is the second sample that we have here. They have a request management extension for the Azure Pack that effectively replaces the built-in self-service portal. It installs a couple of roles. It has a resource provider role, and then it has extensions, both the admin and tenant portals in the Azure Pack, and then it has integration to make itself appear in the Azure Pack. The extender for that does for GridPro does all of that. Then there's also a sample that I'm providing for just general operations manager management packs. By default, PDT only installs management packs in Ops Manager required for integration. So there's 4 or 5 management packs that you have to install to be able to connect VMM to Ops Manager. The core PDT, that's all it does. There's lots of people ask, can they add additional management packs? And so now you can do that using an extender. I'm sorry? MDT integration into Config Manager. I'd have to look at it. It's a long time since I actually really worked with Config Manager, but yes, potentially that could be done as an extender. And the good thing with these is you can create these, you can have partners create these, and they're not going to mess up any of the core PDT files. So go back and check our deployments. The full one is still going. What I didn't tell you about this full deployment, because it's actually scrolled off the bottom of the screen, is that this one actually does have the extenders active. So that status screen is, where are we? What day is it today? That's right. As well as that as being displayed on that screen, that status is logged to a file. So if it does scroll off the screen, you still have a way to see it. If we look at this, we've got to catch it at the right point. You'll see right here at the end of the status screen, it's actually also doing GridPro request management and the Veeam management pack. These are actually simple ways to start to understand the workflow file format, because they're not 35,000 lines, they're more like 400. So this is the one for the Veeam management pack. So again, we've got roles that get defined. So here's the virtualizations extender and the collector. In validation, you can only have one virtualization extensions, but there isn't an equivalent validation for the collector, so you can have as many collectors as you want. One interesting thing about the extender here is there's a prerequisite with a condition, right? So you either install their components on a management server or some other system that has an agent. So what this is saying is the operations manager agent is a prerequisite, but only if the collector server is not the same as the ops manager management server. Right? So if you're following their recommendations and you're putting the collector on a management server, it won't attempt to install the agent. If you're doing it on some other system, it will install the agent for you. There's also an integration defined in here, actually a couple of them. So the management pack itself, you'll notice, is not specified in here as a role. Well, it's specified as a role, but it's an integration role. Right? This is saying that if I'm installing the virtualization extensions service and Ops Manager in the same PDT deployment, then I automatically want to include the management pack. Right? So you don't have to tell it to import the management pack. It knows to do that. And then their installables are just the same as any of the others, except in this one case, there's 2 command lines for the extension server, the extension service, and it's just an MSI with some command line switches. And then there's actually a PowerShell script in here as well that changes group membership of a local group that they create so that whatever service account you're running the collector as can connect to the extension service. It's actually, I highlight it because it's an interesting example of extender that uses a lot of the capabilities. And the reason I highlight this as well is their unattended installation is really well documented, which makes this easy. Pretty much anything that has a silent install can be automated in this way and added to PDT. GridPro one is pretty similar. All you have to specify for GridPro is which server you want to be the resource provider. In a lot of cases, especially in labs, that's probably going to be the same as one of your Azure Pack servers. And then it automatically will determine where to put the admin site extension and the tenant site extension because it goes on the WAP admin site or the WAP tenant site. Then here's the one for the Ops Manager management packs. And you'll notice in this, there actually isn't a role that's not an integration. So there's only one role, and it's actually an integration role. And all this is saying is, if I'm installing Operations Manager, then add these management packs, right? So an integration can depend on just one thing, right? In this case, anything that I wanted to add to Ops Manager automatically, I just specify that one role as a dependency, and it's going to go and install all of them. This also, and actually two of these, also add download locations, so the downloader will know where to go and get those additional files. And the installation here is just a set of PowerShell that goes and imports that management pack using the Ops Manager PowerShell module. Okay. So to prove that these work in a certain way, let's go back to our downloader. And so here's the extender files. I'm just going to copy those over to my PDT folder. And remember, how many downloads did I have before? 99? Now, because the extender's in there, it's got a total of 106 downloads, right? So the extender has been merged in memory, and downloader knows how to read that and go and get the additional files. You'll also see that, in a moment, some of those also require to be manually downloaded. So Veeam, I don't know whether or not there's a public download for that. This just says you've got to go and get it manually and register with them to get their eval. GridPro, 2 of the 3 components for GridPro, there's download links for, but the third one, the resource provider, you have to register with GridPro to get that. So it's that one it's telling you need to go and get manually. And now on my install folder, you see I've got the additional. Yeah, that's a very good question. The question is not related to extenders, related to the downloader. The downloader gets the eval versions of everything, right? The only one of those that is actually different from the full release version, the license version, is Data Protection Manager, right? Everything else, it's the same bits, whether you give it a key or not defines whether it's licensed. Data Protection Manager, if you want to install the license version, you have to get the licensed media, and there's not a public download for it. You've got to go to the volume license site or something like that, right? Okay. And we're getting close here. So I know, because I've run this a few times, that because it's last in the deployment, the Veeam management pack is actually the last thing that's going to get installed on here. Configuration, so everything else is finished except that, and this will take about another 2 or 3 minutes. Okay, some advanced functionality. Last year when I talked about this, I talked about SQL clusters, I talked about VMM clusters, I talked about scale-out roles, getting SQL right. All of those things are still valid and haven't changed from last year, but I don't have time to go over all of those and the new ones today. The slides for those are actually a reference at the end of this, so it's all in the one deck. What I wanted to talk about is some of the other new capabilities that we've added. Scale-out applies to multiple different types of roles, either by having one or more of those roles and the product itself manages it. So Ops Manager, for example, you have multiple management servers. Operations Manager knows how to deal with that. Others are load balanced based scale-out roles. And so last year we didn't have that capability. That just got added in the last few months. We now have the ability to configure or set load balancing for HTTP-based roles. Service Provider Foundation, Service Management Automation, and the Azure Pack are the 3 examples of how they've used that. In each case, all you need to do is specify one or more of those roles and then specify these 3 additional variables, right? NLB name, NLB IPv4, and NLB config. If you want to use Windows network load balancing, specify all 3, set NLB config to true, and it will actually add Windows load balancing for you. If you want to set the component so that you can add a third-party load balancer in front of it at a later time, All you need to do is specify NLB config as false, which is the default, and give it a name, right? What actually happens there, and this is really only applicable to Azure Pack, the Azure Pack has to know the names of referring systems because of the way it uses trusted identity providers. And so what this will do is it will change how Azure Pack refers to each one of those providers, but not actually configure the NLB name. And it does require that you add the appropriate DNS entry, and there's a validator for that to make sure that those DNS entries exist. As a simple example, I thought I had a highlight on that. So Service Provider Foundation in this example is actually getting installed on SPF 01, but I've changed the name, the load balance name to SPF and told it what IP address to use. There's other ways to customize PDT. Extenders is one way. There's other things that you may want to do, and there's two switches, or one switch and one option, that's been in there for actually quite a long time, but I haven't really talked about it yet, mainly because we were still testing that it worked the way we wanted it to work. The first one is setup, custom setup. If on VM Creator you add a switch -setup and then give it a folder name, it will look in that folder as it creates each VM. It'll look in that folder to see if there's a subfolder with the same name of the VM that it's creating. If there is, it copies the content of that folder into that VHD as it's creating it, sets it to auto log on, and if there's a PowerShell script in there, again with the same name as the VM, that will get run by auto log on before any of the installer stuff happens. So a couple of ways that I use this a lot is for actually creating clusters. So we create the VMs, but we don't create a cluster, mainly because the cluster usually requires some kind of shared storage, which PDT doesn't control. So I use it for creating clusters. I also use it fairly commonly for creating a remote desktop session host. So here's that example. This is just a simple PowerShell script that runs as an auto logon that includes managing a reboot that will automatically create a remote desktop session host, tell it where its license server is, create a default configuration for it. So I typically use a session host for all of the consoles rather than putting the consoles on the management servers of the component itself. Then there's also something called post-installer. So setup is custom setup that runs on each VM as it's created before installer runs. If you want to do some other configuration after installer has run, you use post-installer. All post-installer is a script that you put in the same location as installer itself, and once the installation is finished, it will execute post-installer for you, right? The condition on this is anything you want to do to a remote system, you have to run, you have to use remoting to actually go and configure that. So if you want to configure VMM after it's been installed, you could put all that configuration in a post-installer. Then there's this option called max stage. A couple of MVPs asked for this. This allows you to limit how far through a deployment it actually goes. So I said that I pre-staged or I did a partial deployment on my VMs before they started. This is what I used to do it. I just did max stage for SQL. So SQL is already installed. Pretty simple. All stages are cumulative, so you can't just do SQL without admin and server features. Right, GUIs. Where's Benedict? Going up there. Last year, when I asked about who's afraid of XML, at the end of the session I suggested that if somebody wanted to write a GUI for PDT, they could, because I wasn't going to do it. There are actually two of them. The first one is only available to service provider partners right now, but it's developed by internally within Microsoft and by our service provider team. It's called SPORK, or the Operational Readiness Kit. The second one is something that was created by Benedict here, which is actually a PDT GUI that allows you to edit the XML without actually opening the XML file. So I'll let Benedict show you that.
Yes, Robs. Thanks for the nice intro. You hearing me all well? Okay, this sounds better. I'm a Microsoft MVP for Hyper-V, and we're also doing a lot of work with System Center and Windows Azure. I'm from Germany. We're working at a company called Lenity Network Partner, and I've done more than hundreds of installations from System Center with PowerShell Deployment Toolkit. And I'm one of the guys, when Rob asked last year, who's afraid of XML? Well, this question was made for me. And I can't stand the manual editing of XML files anymore, and so I asked around, hey, is there any GUI for it? And, well, not yet. That's the reason why I teamed up with a coworker of mine. His name is Kamil Kozak, and he's a really, really great PowerShell geek. And I'm a System Center guy, he's a PowerShell geek. We teamed up to do this, the PowerShell PDT GUI. It's not a Microsoft product, it's done by us from a partner, so you won't get any support by Microsoft itself, but we're happy to help when there are any problems with it, just ping us. What does it do? It doesn't change the way PDT works at all. It doesn't change the logic, it just helps you to configure the XML files. It does read the default values of the workflow XML, and it does read any values you already set in the variable XML and displays them here. So I can just go into it and change it, like the path for the downloader. I say, okay, I want to create a special path for PDT in here. Here we go. This is very small. I just changed it, and the moment I hit the save button here, our variable XML gets changed. So we don't have to open this in an editor manually. And I can do this with most options of the variable XML. There is also an editor for the configuration of the virtual machines. It will warn you that the first virtual machine will be your domain controller if you select this and you want actually to create a domain controller. This is logic that is done by PDT, so the GUI doesn't change this either. It just tells you, hey, be aware, you select, let's do a domain here, and I can just rename this domain. I can just rename where the service accounts will reside, where the groups will reside. I choose to create all these virtual machines on an empty Hyper-V host. What I can do with the GUI is just to edit the default settings of all virtual machines. So what we see here is I will create all these VMs on one local Hyper-V host. All my virtual machines will reside in this folder. I can change this as well. And all my VMs will currently use 2 CPUs and a dynamic memory configuration with a maximum of 8 gig RAM. I can say, hell, I don't get this much RAM on my machine, so I just edit the default setting back to 4 and save it there. Any individual VM can be edited, which of course overrides the default parameters we just set. So when I say, hey, I really want to do some heavy work with some databases, I just go into the virtual machine, I select it and say, okay, I'll look for a database server here, just select one and have some very basic setting. Where is the host this virtual machine will reside? How does it name? And I say, hey, let's edit the memory configuration for this virtual machine. I just select the memory, add it to this configuration here, and it will show up and say, okay, I don't want to use the default. I want to use more RAM on this machine, and I can just enter it here. I can even create a new virtual machine if I would like to and say, okay, let's do a new VM with a VM name of TechEd. TechEd1, save it, and we'll use all other default values we've provided. So all these virtual machines are created by PDT the same way. They were done without GUI, and we can continue to use this with all other roles. The next part, I can choose whether SQL engines are provided on single server installation, SQL servers are distributed through several servers. I just select them. I can even choose the version of SQL Server used with any parameters like the passwords used, the instances. I can even generate a new SQL instance and say, okay, let's do a TechEd instance on a SQL Server as well. Just add it, and it will be, if I scroll down here a bit, will be added as a new instance for my SQL Server and will be written to the variable XML. If I continue this, and this is the main part where really the work is done and the time will be saved for you when creating these files. I select which roles and components will use which server resource. So here I got an overview and I'm doing all the installation of all System Center components and Azure Pack components. Rob used the orchestrator and assembled, so I will continue here. And we have a runbook designer on RD01, and I will just remove this row there, and it's removed from my variable XML. It's also easy to get this back here. Just go to System Center 2012. looking for the orchestrator, there he is. Select the runbook designer and say, I want this go to server RDR1, save it, add it to the machine, and there it's back on RDR1. So it's very easy to use. It's just a small PowerShell GUI. It doesn't change the way PDT works. You can use it. And if you have done all this, you just go to the next and run the validation process. And it will run the same validation. The PDT it just uses your existing components. We have taken some of these validation processes into the GUI itself. So when I'm in the roads mode, and what Rob tried to do some minutes ago to add the orchestrator console to the same server where the service manager resides, trying to add management server for operations manager to as service manager VM, try to add it. It will actually warn me that this is not allowed, so you save some time here in the validation process as well. This is a PDT GUI.
We're right out of time, but there's one other thing I want to show you. How are you making this available?
Well, to save some time, I already put this on Tech and Gallery, and so you can use it. As of now, it's free for everyone, and I encourage you just to use it, report any bugs you find, feature requests, and some feedback through us just to the Tech and Gallery page.
And there's the blog post going live announcing this is available. So just go to the Building Clouds blog and you'll get to the same thing. I want to show you the results of this one deployment, and then we'll wrap up. So this finished. You'll notice that the icons got added to the taskbar, and I want to highlight two things. First, I'm going to go to the Azure Pack site. These links also got automatically added. And then also show you in Operations Manager. See which one of these comes up first. So here in the Azure Pack, once it loads, it's warming up. Of course it goes slow when I'm running out of time. Here it goes. Okay, so new Azure Pack deployment. Here you see there's the Grid Pro request management. It also already has a connection to its resource provider defined. Here's all the connection to SMA for automation. And once this comes up, we'll have our service provider IaaS cloud as well. In Ops Manager, you'll see the Veeam management pack is already installed. And if you look at their extensions topology, it should have already started to actually monitor the Veeam infrastructure itself. So those are the two extenders actually showing working. Out of time, but was going to talk about a couple other things that skipped this. This is the advanced configuration I did from last year. There is a whole section on troubleshooting, which I could do another session on, but based on what just failed. So, how many products in System Center? How long does it take to install? An hour. Thank you. How many screens are there? One. How many post-setup integration tasks are there? Doesn't matter. You don't need to know about them anymore. Who's afraid of XML? Use the PDT GUI. That thing's awesome. So, all of this is available on the TechNet Gallery. There's a blog series on the Building Clouds blog, which is essentially where I document how to use this thing. There's a YouTube video, for some reason, of a deployment completely sped up. This doesn't replace the software distribution or virtualization management capabilities in System Center, but it does allow you to get them deployed quickly. That's automating System Center deployments with the PowerShell Deployment Toolkit. I'll be in the expo tomorrow. I'll hang out here for a while if you want to ask questions. Go deploy some System Center. Replace appropriate planning. The services guys, the consultants in the room always appreciate it when I say that. You can do a default deployment with some of the samples I provide and it will work, but it won't work very well. You have to define your deployment, you have to do your planning. Don't skip that step. Then you go and download all the bits. if you can figure out what they are, some of those combination of prerequisites and everything, SQL and everything before. Then you go and you install a bunch of servers. Typically today you'll do VMs, you may still have some physical servers, but you have a bunch of server instances that you set up that you're going to now go and deploy System Center to. Then you create some service accounts. Then you log on to each one of those servers and start installing the prerequisites. Actually, what you probably do is you run setup for whatever System Center component you want to install, and it says you're missing the SQL native client or the SQL command line utility. And so you go and you download that and you try and install that, and it says you're missing the SQL native client. So you go and you download that, and eventually you get to the point where you can actually install one of the System Center components. But you install prereqs, you go ahead and you install SQL, then you install SQL again because you did it wrong the first time. You got a collation wrong, or you put the log files in the wrong place. You didn't find that out until you tried to install Service Manager about 2 weeks later, but you're probably going to install SQL several times. Or you're going to go to your DBA team and have them install SQL, and they're going to lock it down so tight that nothing can ever use it, so then you're going to do it yourself. But eventually you get SQL installed. Then you figure out which of those service accounts need which permissions. Typically administrative permissions, but not always. Then you go and you install your first server role. And then probably install other server roles, depending on which component you're installing. And then you figure out how to give people access to use that component, so you give them admin permissions to the component. And then if you know about this post-setup integration thing, you go and you do that. Then you install a console. Then you tell the console which one of those multiple servers it needs to connect to. Then you install some agents. Finally, you get to manage something, right? This is not an optimal experience. With PDT, it's very different. We don't replace all of it, but the bulk of this is replaced by 3 scripts in the toolkit, in the deployment toolkit. We do not automate planning. You still have to plan your deployment. So we're going to walk through each one of these and look at how PDT actually automates this. So first, you define your deployment. And here comes the XML. This is actually very simple. There's 5 files in the deployment toolkit. There's 3 scripts, 3 PowerShell scripts, and 2 XML files. The only one of them you need to change, modify in any way, is variable.xml. This is the one that defines the deployment that PDT is going to do. The download itself off the TechNet gallery comes with a couple of samples. So at its simplest, you can just go and modify, edit that sample. What you do in variable XML, you specify some global settings. So you'll have the user and company name that the components are going to get registered to. There's a service account that's actually going to be used for the installation. There's a source path to where all the bits are, and we'll get to that in a moment. Then optionally, you can also put in product keys. Then you specify settings for each component. Typically, that's just a service account or a number of service accounts and passwords for that component. There may be a couple other things in there, but typically it's just service accounts. You can define a lot more, but that's more custom. By default, all you have to do is the service accounts. Then you say which servers you want each one of these roles to go on. So database roles, you've got to specify a SQL instance as well as the server, but everything else, you just tell it which server it's going to go on. For each SQL instance that's going to get installed, you have to specify which version of SQL you want to use, 2008 R2 or 2012, and which group you want to be the administrator of that SQL instance once it's installed. And don't worry, because the installer, the script itself, actually validates everything you put in there. Right? So if you get something wrong, 95% or so of the time, validation will fail, and it won't let you continue. There are a couple of things that it still doesn't quite catch, but most of the time it'll validate what you specified. So this is a sample. This is a very simple example, and I use Orchestrator as my examples a lot through this, mainly because Orchestrator is really quick to install, so it works well for demos. But this is a simple Orchestrator example. We've specified the installer account. That's not going to be used for any of the services. That's just used for actually performing the installation. We specify variables for the component, so in this case it is just service account and password. Which servers we want those roles to go on. So this is a separate database server one server for the orchestrator box, and then I've got a remote desktop. Good afternoon, or is it good evening yet? One of those, right? Almost evening. So is the last session of the day better than the first session of the day in the schedule? Yeah, okay, good. So thank you for coming. This is automating System Center deployments using the PowerShell Deployment Toolkit. I'm Rob Willis. I am a Principal Program Manager in the Windows Server and System Center engineering team in Redmond. And I'm the guy on the Building Clouds blog team that put together this thing called PDT, or the PowerShell Deployment Toolkit. How many people are familiar with the Building Clouds blog? Okay, I'll be referring to that a little bit as I go through this. How many people have been to one of my sessions on PowerShell Deployment Toolkit before? A handful, okay. I'm going to give a lot of the same overview that I've given before, and then talk about some of the new capabilities that we've added in the last year. PowerShell Deployment Toolkit, or PDT, is a set of scripts and knowledge that you can use to deploy stuff, and the samples that we provide with it are really focused on deploying System Center. So I'm going to start with some questions, and if you've been to a session before, you know the answers, so you can't answer. How many products make up System Center 2012 R2? Shout it out. 8? 7? Who said 1? 1. There is one product called System Center 2012 R2. You buy one thing, you license one thing, and you get a whole bunch of stuff as part of that. How long does it take to deploy that one product? Somebody say a year? It takes too long, is the only answer. I've had answers from a week, 2 weeks, a month. I don't think anybody's ever said a year before. It takes too long. Actually, the answer to that first question, one of the former directors of program management, he asked the question, and his answer was always just too many. There's too many products. There's actually only one. How many screens, if you're doing a manual installation of all of System Center, including all the prerequisites, including SQL Server, how many screens do you click through? 1,522? It's a lot. I was the PM for the Unified Installer in the... We will come back to those as we go through. So, HA deployment, VM creator. So, System Center 2012, one product. That one product is made up of a number of components, and somebody said 7, and that's the real answer in terms of number of components. How many people here are using, is anybody here not using any of this? Okay, how many people are using 2 or more components? 3? 4? How many are using all of it? We got 2 hands, 3 hands. Okay, the point is there's a lot of value in System Center. And really get the value, you get it from using all of the capabilities in here. And actually, I tend to include the Windows Azure Pack as part of this. It's not part of System Center, but it is very much included or wrapped up in the deployment. But you break that down a little bit. From components, you now have roles. Right? Each one of those components has a number of roles. This is by no means a full list of all of the roles. If you really wanted to take it to an extreme, Windows Azure Pack also has websites, Service Bus, SQL Cloud. Configuration Manager has a lot more components than here. These are basically the roles that the core setup of each one of these components actually goes through. Then you take it a step further. Each one of these roles has one or more prerequisites. And there's a lot of them. Some combination of this you have to install before you can deploy those roles. And actually, this is by no means a full list. This was the list for System Center 2012. There were more for SP1, there's more for R2, and there's a lot more for Azure Pack. So the set of things that you have to get installed and set up to do a System Center deployment is pretty extreme. The goal here is to make this truly a single product with a single deployment capability so that you don't have to know what prereqs are needed. You don't have to know details of how SQL needs to be configured. You don't need to know how to integrate these things with each other. And increasingly, especially with the Azure Pack, that's becoming more and more complex. You just deploy one thing, and you get to value a lot quicker. Because installing stuff is not interesting or fun. Using the capabilities it provides is really where you get the value. So what's the experience today of installing System Center? First, define your deployment. I don't care how much automation you have, it does not require the original System Center 2012, so I apologize for that, but I did actually count it, and that was actually a very simple deployment the Unified Installer did, and there were 422. If you're doing a real deployment, there's a lot. How many post-setup integration tasks are there? What on earth is post-setup integration? It's too hard. Who's afraid of XML? Come on, don't be shy. Who's afraid of XML? Okay. I'm going to have a pleasant surprise for you by the end of this presentation. So we'll just leave it at that. But I am warning you, there is manual editing of XML during this session. Please don't leave. There's a good answer at the end, but I want you to understand how this thing works. So again, there's some good news coming. I'm going to start with some demos. And the reason I do this is because I'm going to do a few deployments, and we're going to take a look at them as we go through, and I want them to be finished by the time I'm finished talking so that we can look at the results. So I'm actually going to start 3 deployments. The first one is what I call a full deployment, if I can type, and I'm going to just tell it to skip the validation here. Okay, this is deploying more or less everything that's in System Center 2012 R2. The second one is a HA deployment. This is maybe a typical service provider type deployment. There's a SQL cluster, there's a VMM cluster, there's load balance roles of a number of different things. So a full HA deployment kind of in a service provider scenario. And then the third one is a lab setup. So I'll be honest, those first 2, they're actually partially deployed already. They don't complete in an hour anymore. So I did a partial deployment, and they're picking up where that one left off, and I'll explain how we do that later on. This one is a complete deployment. Everything from absolutely nothing to deployed. It is a relatively simple one. It's just a 3 VM orchestrator installation, but this is on a Hyper-V host that currently has no VMs. So I'm going to just start the VM creator here. And so now I've got my full deployment started, my HA deployment started, and VM Creator lab deployment started.